Welcome back to this new episode for Let's Code Games. We're actually a little bit late today, but I hope that people will still find the stream. And we just continue where we left off last time. So, actually last time we implemented picking up objects like so, and we can throw them. And there are a couple of features that continue this. So this feature is not quite done yet. So I need the sword here. So I want to make sure that we can walk while we are carrying an object, because right now we cannot do that. And then we also want to implement some touch controls, because that is something that I want to see working for this game. It should be fairly simple, so we can see I actually have a tablet here, and I guess we only have to test it a couple of times. So yeah, let's see if the touch controls, if we can make this work and interesting for you guys. But I really want to have the touch controls in there, so I can play the game on my phone or on tablets when I'm not at the computer, and so we can do more testing and stuff. Especially if there is more of the random level generation in there, the game can be played over and over again. So I really would like to test this on the tablet. And then we also have some animations that are yet unused where we can push objects. So we have another type of stone here, which is more square-like. Is it an environment? I think yes. Like this. And we want to add that into the game, so we can and those can be pushed around. So we have some animations where the character is pushing against the objects, and yeah, I want to implement those, because I think when we have the walking animations, the walking and carrying animations in there, and the pushing animations, we are pretty far along in terms of feature set what the character is concerned. So I kind of want to get this in, so we can start focusing on building more of the enemies and building more of the random level design and stuff like that. So yeah, let's see how far we get today. I think we're going to start with the animation stuff, and I'm going to do the touch controls in the end, I think, because the pickup stuff, we already have that in there, and I prepared a little bit this time, so kind of like a cooking show. I already prepared something. So I prepared the animation clips for this, so I don't have to set them up during the stream. Let me show you the sprite sheets here. So we have the lift item sprite sheet. Already had the walking animation in there last time, but we didn't get to implementing it. So I made an animation clip from these walking while carrying an object frames, so we can put that in. And I also created the animations for the pushing stuff. Alright, so let's go over to the animator and see what happens when we're picking up an object, just to remind ourselves what is happening, and then we can see that that we extend this stuff. Go to the animator here. Okay, so when we walk over to a bush and when we're picking it up, we are right now, you can see here we are not in the base layer, which is this. It's actually not, it's actually jumping back to the, let me pause this here. So this is our base layer, and we are in the idle state right now. So the idle state is a substate machine, which means even though this state is active right now, there's actually much more to the state. As you can see here, we have the idle shield, we have a regular idle, we have an idle pickup object, we have the pickup object in animation in here. So there's tons of stuff happening in the idle substate machine. And we kind of want to do something similar for the walk substate machine, because as you can see here, this is also a substate machine, which is indicated by this different shape. So regular states are square likes, and the substate machines have this little arrow shapes on both ends. So in the idle substate machine, we have, first of all, we have a parameter called isCarrying, which is basically true whenever we are carrying an object and false if we don't. And you can see here in our idle, we have a transition to the pickup object animation, which is called when isCarrying is set to true. So when we're in idle, or when we're in idle shield, and isCarrying is set to true, then the transition goes over to the pickup object animation. And when that is done, basically it's just 4 frames picking up the object. And when that is done, we're transitioning over. So there's no condition here. Basically, when this animation is done, we're going over to the idle pickup object, which is basically just the idle in the idle animation with the arms up. And now we can see here, if is moving is true, and that is happening for all 3 idle animations, we exit out of the state machine, and we're transitioning over to the walk state machine, which right now has the walk and the walk shield animation. And I want to add the walk pickup. I think, let's see, I'm not sure how I called this animation. So I have the move right pickup object. Okay, so I've walk shield, walk, and then we create a new blend tree, just like before, because this walk and this walk shield is those are blend trees, which means we are blending depending on which direction we are facing. We are either showing the move right, move left, move up, or move down animation. And we're going to do the same with the walk. How would I call that? How did I call that in the idle state? Let's go over here. Idle pickup object. Okay, so let's call this walk pickup object as well, so it's consistent. Walk pickup object. Let's quickly set up this blend tree, which is, as always, a 2D blend tree. And the parameters we are looking for are direction X and direction Y. And then we add 4 motion fields here for each of the directions. So this is X positive, X negative, Y positive, and Y negative. And then we have move down pickup object, so this is down. Move left is X negative. Move right, X positive, and move up is Y positive. Alright, so this is our state machine here. Let's quickly check if we set up the animation correctly. So let's go over to the animation here. For our main character, we go to move left pickup object, let's press play. Alright, and that's working. What is the speed of the move left? It's 12. Alright, okay. Move this, yeah, and the speed is 12, so that's fine. Okay, so we set up this blend tree, and then we need to set up the transitions for all of these here. Basically what we're going to do is a transition if isCarrying is true, then we transition over to the walk pickup object. It doesn't have an exit time, and the transition is always instantly. And the same, and then back as well. No exit time, transition duration 0. And now we have to set up two conditions here. So first of all, if is carrying is false, and then you can see here if has shield is false, then we go back to the regular walk. And if is carrying is false, but has shield is true, then we go over to the walk shield animation. And also we have to have a transition from walk shield over here when we're carrying something and we are in the shield stuff, then we want to go over here. And lastly, we need to set up the exit transition. So if is moving is false, again, no exit time. I really want to have default, to be able to set these as my default parameters here. Anyway, I need to check that if that's possible somehow. Okay, so if is moving is set to false, then we exit out of the state machine. This should work. And then there's something that we need to do here. So basically, when we get into the idle state machine, you can see here, if has shield is true, then we go to idle shield. Otherwise, we use the default transition, which goes to idle. So basically, the default transition doesn't have any parameters. Basically, what happens here, it is marked as yellow, and when you get into this, so when you come from the entry point, and none of the transitions that have conditions are met, then we use the default one and go to idle. But, so if has shield is true, we go to idle shield, but we can also go to pick up object immediately. So if is carrying is true, then we want to go to idle pick up object immediately. And I think we need to set something up here as well. Basically, yes, from in the walk substate machine, we need to set up a entry transition. So if is carrying is true, then we immediately go to walk pickup object. Great. So this is the setup for our animation stuff, and now we need to enable our character to walk while he's carrying an object. So last time we just froze the character, at least we froze the movement. We didn't freeze the direction, but we froze the movement. Let me open this Visual Studio here. So basically we're going to reverse what we did last time and just remove the part where we're frozen when we pick up an object. So we're picking up an object in the interaction model. So pick up object here, and then set is able to attack is false. That should remain like this, and then set frozen to true. Is direction frozen is false, and effect game time false. So basically we just remove this part here. We don't want to freeze the character, and we don't want to unfreeze him when we're done. And this should be it, actually. So let's see if this works as expected. So we're in idle pickup object, and alright, it does work and the right animation is playing, but the parent, the pickup object parent, is not yet set up in our animation. So we need to do that. But it's hard to see because the object is in the way, but the right animation is playing, and we can even see that in our state machine here. If it wouldn't jump around all the time. So we are in walk pickup object here. And when we throw it, we go back to the regular walk. Okay, so that works. So let's set up the animation so that the parent is set up properly. let's see, pickup object and the parent. So the parent position for copy component for object, right? So we have to figure out if the parent is the same for each direction. Let's test that quickly. Oh, it's harder to test that now. It looks like it though. Okay, so pickup object, right, the parent. Let's just copy it properly for each direction. So copy component, this is the pickup item parent that we're copying right now. And then we go to move right pickup object. And you can see here that the parent is in the center. That is why the object was jumping around. So basically we're setting the position to the same position it was. Yeah, this looks good. And then we do the same thing for all the other directions. So go to left, copy the position here, copy the component, I mean, go to move left pickup object and move the component and then paste the values. All right. And then do the same for up. Copy component, move up pickup objects, and I always do this in the first frame only, so the other ones are just following suit, the frames that come after the first one. And for the last one, going to pickup object down, picking this here, copy the component. Oh no, I pasted them now. Copy the component, please. And go to move down pickup. Okay, this should work better now. Let's press play here. Pick up the object and walk around with it. Yeah, cool. Now we can walk with an object in our hands. Alright, and that was the first task for today. This was a quick warm-up task, but it's always satisfying when we can strike a task. Okay, so let's add the push objects. So this is actually going to be an interesting problem to solve. So we need to see how we're going to do that. How we're pushing an object. Let's go to a scene here. Just go to the start scene and create the push objects in here so that we can easily test them. We have the heavy brick here. And the heavy brick. Alright, well, for now we just put them on ground objects and layer 10 so it's visible. And as always, we're going to create it, create a duplicate of it, pull it into the same object and name it visuals. And then we're calling this heavy brick blue. So the sprite renderer, as always, is a child of the object, and then it needs a collider, so box collider to D. And then we can make a prefab out of that. Okay. Let's go back to our main scene. So when we press play now, we do have this blue brick here, and now we can start adding functionality for it. And it's actually too small. What's going on? I think I haven't set up the proper pixels per unit. Yes, that's it. We were working with 64 here. In that case, I'm sure I need to rescale the collider. Yeah, I was kind of confused why it was too small, because it should simply be 1, 1. Alright, so there's our block. And right now we just walk against it. And there are two different things that I want to achieve here. First of all, if we walk into an object that we can walk past, it's really not nice that the walking animation is continuing to play. And it's really, we can just use one frame of the push animation there. So whenever if we idle, then we idle, that's fine. But if we continue to walk into a wall, I really want to have the push animation, and not the push walking animation playing, but maybe just one frame. This way we acknowledge that there is a wall better than just running into it, which just looks stupid. And I really don't like games that do that. So okay, so let's think about how we want to set up the pushing here, and how we want to find out if we're pushing something. So let's solve the problem of walking against the wall, basically. So we can have, I mean, what do we need here? Do we need one boolean or do we need two? I think we need two. So basically we need to tell the animator, first of all, are we pushing at all? And then, are we pushing and moving at the same time? Because I don't think we can use the is moving here, because we're only using the pushing animation while we are in the walk substate. Because when we are idling, so when we're not walking, even if we are right against an object, then we are not pushing against it. We only push against the object while we're walking. So basically, the is moving parameter already determines that we're in this walk substate machine. So we cannot use that for our pushing stuff. So we have two new parameters. Is pushing what do we call it? We can have is pushing, and then is pushing and walking. Well, I don't know. We just leave it at that. I mean, it's really, that's what it is. And then for this, we can set up a new blend tree again. Can we duplicate the blend tree? Yes, we can duplicate a blend tree. That makes it a little bit easier. So we call this push. I already created the animation for this, so we call this push idle and push move. So we have push idle, and then we duplicate that, and then we have push move. I mean, let's just do push idle for now, because just one thing at a time. So we can go into push idle basically just from walk and walk shield. If we pick up an object, we cannot go to push idle. So let's make this a little bigger here. I mean, we could, let's just do the walk up here, and this way we can do the pushing a little more down below those two. It should be visually a little easier to understand and less cluttered. So if we're walking and then make transition, if no exit time as always, no duration, if is pushing is true, then we go here. The same from walk shield. If is pushing is true, then we go here and we go back if we're not pushing anymore. Is pushing is false, and also if has shield is false, then we go to walk and we do. And for this transition over here, there's a lot of transitions that we're setting up right now, but that's how this works. So if we are not pushing and we are carrying a shield, then we go to walk shield. And then we need to change these here to our push idle. So this is down, push idle left, push idle right, and push idle up. Okay, so how do we determine the is pushing? And basically last time we started to set up something. Have I removed this again, or is it still here? So we have a movement. So we have a movement model and a movement view, which basically takes care of the walking stuff. But not all the enemies will. I want to reuse that. So this is all in the movement model, but the enemies won't be able to push stuff. So let's put the pushing in the movement advanced model, which is empty for now. And this way we can just put this pushing functionality on the main character, and we don't have to put it on the other characters. Okay, let me see here. So in the, let's see how we determined if we are walking or not. So in the movement view, is moving, oh basically we have this is moving state. This is great. So let's, update pushing. Oh no, but we want to do that in the view and not in the model. So the advanced view, basically what we're going to do is we see if we're moving. So if the model is telling us that we're moving, but our position is not changing from the last frame, then we're basically up against something. So, and maybe we can even count if we are not moving for maybe 2 or 3 frames, then we must be pushing something. And maybe let's put this in fixed update as well. So, update pushing. For this, we need to store a last position, and then we need to store a counter how long we've been in that position. So last position counter. Let's not make it frames, let's make it time-based. Okay, so So we're checking our current position. So if our current position is not like the last position, or if it's, let's do a positive here. So I always like to have a positive if statement because it's much easier to see, so easier to read quickly. So if the position is equal to our last position, then we want to do something. If it's not equal to our last position, then we're setting our last position to our position. So if our position has changed, we make sure that we store that. If our position has not changed, and when we store that, let's not name this counter, but time, we also store the time when we change the last position. So if the position is equal to the last position, and now we're doing two different things, and if the model is telling us that we are moving, the advanced model, but we also want to have a reference not only to the advanced model but also to the regular model. Or do we? No, we don't actually. Let's make this properly. Let's make sure that we are doing all of this calculation in the model actually, and then we're just passing this along, because the model is responsible for changing the states, and the view is only responsible for displaying the states. So update pushing. Let's copy this over here. Copy those. We need the variables here. All right, so if the movement model tells us that we're moving, and the last position time so we can make a method here, get time in same position, which is basically just the current time minus the last position time, because the last position time only changes when we are actually changing the position. So this is the get time in the same position. So if get time in the same position is bigger than zero point 0.05 seconds, then we want to be pushing. And this is what we're sending to our animator. So is push, no, set boolean is pushing. I think this is what I named it. Okay. Fixed position. Now this is update. Oh yeah, but this is obviously in the view. So basically what we are doing is we cannot do we have an empty positive statement here if we're doing it like this. So yeah, if we only have an empty positive statement, that doesn't make sense, so we remove that. So if the position is not like the last position, then we change all that, and then we can have a public method that that is telling us if we are pushing something. And basically it returns if the movement model is moving, so what we did earlier here, and if the get in same position. So if the movement model is telling us we're moving and we're in the same position for more than 0.05 seconds, then we are pushing. And we can use this is pushing in our view here. And in this view, we send this to our animator. Is pushing okay, so let's see if this worked, because there was a lot of it. Let's go to the animator. So we're in idle right now. If we walk, and then we're pushing. We're still walking, but we are in the push frame. So let's see, we walk against it, and then we push it. I mean, we're not pushing it yet, but I think the is equal for the position is too finicky. So let's not check, because there was this, and there's always a small stutter in there. So let's check what's going on here in our advanced model. So let's check if the distance between our position and the last position is smaller than is bigger than 0.05. This value is just something I just thought of now. But basically, if there are small, tiny movements while we are pushing something, we don't want to always jump back and forth between stuff. So let's see. But now we're going into there as well. This is not good. It should be so even smaller maybe. Let's see. I mean, there's still. This is not. I mean, the pushing part works, but there's sometimes it's playing the pushing frame even though we're not pushing anything, especially when we're just starting to walk somewhere. It's really bad that we cannot zoom out here. Is it always centering the entry node? Let's make this a little smaller so we can see what's going on here. I mean, it's always starting with push idle. This is a tough problem because detecting that we're pushing something is it's a little hard to do it. I mean, we could we could make sure that we're not doing this when we just start to move as well. So let's go to the movement. Movement starts time. So we're checking if we were moving as well. So update was moving. So if, let's see here, what do we want to do? Eventually we want to set was moving to our is moving, and if was moving is false and is moving is true, basically this means if is moving was false in the last frame and it's true in this frame now, and then we just started moving, so we want to store that time. Movement start time, and then we also have get duration of movement, get time moving, get time moving. Oh, so what should we name this? Get time moving, get the duration of movement, get moving duration, I think. And again, we're basically using the current time and subtracting the time that we stored from that to get the amount of time that we're moving. And then we can use this in pushing as well. So if moving is true, and if the moving duration is bigger than like 1/10 of a second, let's say. So basically the character only starts pushing if we have been moving for over 1/10 of a second. And this way we will make sure that there's no jitter when we just start to move. There's still a jitter though. Did I do something wrong? Yes, I don't update the was moving. So spray again, and then if we're moving, it still starts in the push idle. Why is that? It shouldn't start there. So is pushing is always flashing true for a little bit, which should not happen. So let's see, if was moving is false and get moving duration. So if is moving is false, then basically we don't have a movement duration. Maybe that's it. If is moving is false, then we haven't been moving, of course. Let's see if that might be the issue here. Nope. The is pushing is still flashing true for a little bit when we start to move. is pushing. So if is moving is true, get moving duration is bigger than tenths of a second. Let's get some values here. Okay, so 0, 0, 0. Something is not quite right. Oh, the last position. Oh, okay. Movement start time. I need to use the movement start time here. This couldn't have worked at all. Alright. Just used the wrong variable. But I think the basic idea was correct. It's still flashing true though for just a second. Let me get a gamepad here so I don't need to have focus in the game view to move. I can use the gamepad. Oh no, that still doesn't work. Okay, so this is very hard to debug. Why is the is pushing is flashing true? See if the values are just too small, but that shouldn't be the problem though. Maybe we can make sure, so if moving is true and was moving is true, this way the first frame is excluded. It might just be an execution order issue here. Okay, so that works better, but there's still flashing in between. So get time in same position. Maybe raise that to 1 as well. And make this a little smaller. Okay, so now the is pushing is not flashing anymore. And if we walk against the wall for more than 1/10 of a second, then we start basically putting our hands up. And this is great, because now we're not continually moving against against a wall if we go there. But since we haven't set up the transition from our walk pickup object, as you can see here, we are still doing that. Maybe we can transition to idle. We can use the idle pickup object there as well. So if no exit time, no duration, and if this pushing is true, then we go over here. I mean, can we go from any state to exit? No, we can't. Okay. Any state up? We can't as well. I think now I'm just alright, so if is moving is false. I mean, it should actually be any state. If we're in any state in this one and is moving is false, then we want to exit, but it seems like that is not working. So we're going to have to transition from every state to the exit state, which makes this really, really messy. So I have to check next time if there is a better way for this. But if it's moving is false, we want to exit out of the walking stuff. But basically, if we're pushing and we are carrying something, then we just don't want to continue to walk. Otherwise, we will still just run into the wall. But like this, we just stand before it, which is nicer than just continually running into the wall. Okay. So now that we're pushing something, we also so now that we know that we're pushing something, we want to interact with something. So we want to have pushable objects that move when we're pushing them, like this stone, for example. So we know that in our advanced model that we're pushing something. So we can create a new type of object, a component, which is basically a pushable, just like we have with the interactable stuff here. So our bushes, for example, they're interactables. And our sword is an interactable as well. So we have an interactable here, and just like we have this interactable component, we want to have a pushable component. So we can just put that on whatever object, and then when we're pushing when we detected that we're pushing something in our advanced model, basically when we move up to something but we don't move, then we just look in our surrounding if there is a pushable object. And then we can figure something out if we're looking into the direction of that pushable object. So basically we can figure out, are we pushing against an object that has a pushable component attached to it? And if so, then we want to actually start to move this object slowly in that direction that we're pushing it. So let's create a pushable component here. And we're attaching this pushable component to the object, the brick object that we just created. Where's the prefab for it? Environment, heavy brick blue, and this is pushable. Okay. So first of all, we have update pushing, and then we have, let's create a new method, update pushable objects. And basically what we're doing, first of all we check if we're pushing is false, then we don't want to do something here. If we are pushing, we want to find the objects that we are pushing against. So when we're doing that similar to our, let's go to our control, on interact, on attack, press on action, interact, and on interact. So find usable interactable. We can copy most of this. Actually, so now let's do this. So the update pushable objects. So if we are basically duplicating most of this code, which that means we should refactor this. But are we? So what we can do is public get close colliders, that we can do public. Because this is something that we can reuse, but it's an array of collider 2Ds. And get close colliders. And then we can use this get close colliders method here. So in our advanced model, character interaction model, let's get this as well. Get close colliders. So that's a start. Box no, it's an array of collider 2D. And then we go over each of those close colliders and see I forgot to tune in today. Yeah, I'm sorry. I mean, actually we're not streaming at the same time as we do always. I was 2 hours late because I wasn't here in time, so yeah, I'll upload this stream to YouTube tomorrow so you can see it there. No worries. I just wanted to make, even though I was late, I wanted to make sure that we still had a stream today because yeah, I want to make this consistently, so. Alright, so, but this time we're not looking for an interactable base, but we're looking for a pushable. Collider, pushable. And if the collider doesn't have a pushable component, then we don't want to do anything. So, if it has the pushable component, then let's first of all just debug found pushable and see if this works up until this point. So let's press play here. If we're pushing over here, then nothing is happening on the console. If we go over to the brick and push it, then we have found pushable. Cool. And this really just triggers when we're pushing against the pushable, because we need to be very close to the object. That works. But we also need to make sure that we're facing the object. And we already have that direction to interactable. So basically we're doing something similar here. Yeah, let's copy this over. So basically we're looking for the closest pushable. Angle to closest pushable. We're copying a little bit of code here, but that's fine, I think. So getting the direction to pushable. Just copy this over because I renamed this a little bit. And collider pushable. And we can put all this in a method as well. Find closest pushable. Okay, so we have this method find closest pushable. If closest pushable is 0, then we don't have any, so return that. Otherwise, we now basically we found a close pushable that we are also facing. So this is the code that we copied over from the interactable here. We're basically checking for the angle between the facing direction and then the direction to the pushable, which tells us how far off we are, and if this angle is below 40 degrees, so basically it's an angle of 40 degrees in front of us. If it's smaller than that, then we are able to push this because it needs to be in front of us. Yeah, so this is what we just copied over from the interactable here, because that's the same kind of thing. So if we found the pushable, I mean, what we can do now is we start to push this object. So in the pushable, let's basically have a method here that we can push it in a direction, and then we basically just move this transform position times the normalized direction times the push speed times time delta time. So when we basically we call this in an update method every frame to push this. So closest pushable, if we found a closest pushable, then we want to push this in the facing direction of our character. And while we do that, we also want to make sure, and first of all, let's see if that works. So heavy brick blue, let's give it a small push speed here. And then if we walk against it, we should be able to push it. Yeah, but as you can see here, I mean, it's pushing it very, very slowly. But also what you can see here, while we're pushing it, we're also constantly going back to idle because we're leaving the position that we're in. So first of all, let's see what the actual speed is that we want to use here. So maybe 1. Yeah, I think so. But now we also need to enter a state of we're pushing an object now, so we need to continue to push the animation, but also go into the push while walking animation. So this should be a new state that we are in. So I mean, we can just save this closest pushable in the class. So if we're pushing if we're not pushing anything, the closest pushable should be null. Otherwise, we just find the closest pushable and save that. So we can use this. So first, we can use this in our method here. If is pushing, basically let's refactor this a little bit. So if we're not moving, then we are also not pushing. And or if was moving is false, then we're also not pushing. Perfect. Then if we have a closest pushable, then we are pushing always. So if we found a closest pushable and we are moving, because we determined that here, then we are always pushing, even though so if we have a closest pushable, if we push against an object, then we're not even checking the moving duration or the time in same position, because we are moving, we're pushing something. So let's see what that does. This is actually a quite complex thing, so hopefully whatever I'm saying makes sense. So let's push this. It works, kinda. Okay, so the animation part is working. We shouldn't be able to change direction while we're pushing. But the animation part is working, but why aren't we pushing anymore against the object? Oh, fine, because we removed that, of course. So if we still need to push against that object, of course. So get our facing direction. Alright, this works. Now let's increase the speed again for a little bit. Oh, we need to use the physics to push the object, otherwise it doesn't care about other colliders. Alright, so basically what that means is a pushable object always needs a rigid body. So let's make sure we require this. And then add a rigid body here. The rigid body, well, it has a fixed angle, that's for sure. Is it kinematic? I think it should be just kinematic. And then what we can do is, well, first of all, we get a reference to our rigid body. And then when we push the object, then we basically want to call move position. And the cool part about move position, let's see if this works. So move position basically does the same thing as transforming it, but it should take physics into account. But since this is a kinematic object now, I think we still can push it through other objects. Let's see. This is actually what? Okay, so this is not what we want. Let's see if this works. No, we can still push it through. Okay, in that case, so this doesn't quite work. In that case, that is an interesting problem. I mean, we can set the velocity. And there should be a vector too, of course. We can just set the velocity, but then we also need to make sure that we're setting it back to 0. Or we can just increase the drag. Let's set the velocity first and see what happens. I mean, now we should have a sliding object, because when we push the object, we're setting its velocity, but we're not setting it back to 0 again. So it slides, it slides, it slides, and it's not colliding. Oh yeah, because it's still a kinematic object, of course. So let's remove the is kinematic. It also shouldn't have gravity, of course. Otherwise it just falls down by itself. Okay, so we can, it's basically like an ice block now, which is fun, but not really what we wanted to have here. What happens if we the heavy brick, what happens if it has a very high linear drag? Alright, so when we stop pushing it, then it stops moving. That works, but now the animation is not working anymore. And that might be... why is that? Character interaction model. Maybe if we have a closest pushable, we should just stop looking for new closest pushables, because they're probably, when we push them, we push them probably too far, so we lose connection to them. So if we have a close pushable, we just stick to it. And then if we are not moving anymore, then we just set this back to 0. I mean, we could also check the distance, so if it gets too far away, then we can remove this as well, but for now this should work. And there's something else that I wanted to do well, anyway, let's see if this works. It doesn't. Oh. Or no, wait. I'm confused. There is so much stuff going on here. Why are we not able to push it? I think that might be a collider issue, because because it's not a kinematic anymore. Linear drag, gravity still. Maybe if we just increase the mass. I actually forgot to store the linear drag, so that might be an issue as well. Okay. So if we increase the mass, that works, but then we need to increase the push strength. So increasing the mass basically makes sure that No, this is all not very nice. This is not very nice at all. Let's take a different approach here. Having a second rigid body here makes this very, very complex. So another approach would be what we can just parent the object that we're pushing to our character, because then the collider of the objects that we're pushing merges with the character, so we cannot push the object into stuff. That might be a little easier. So basically we only need the pushable component, and it's empty, it's not doing anything. So if we found a pushable, then we want to parent this object to our character. So the closest pushable parent should be our character, and if we're not moving anymore, then we remove the parent basically. Let's store the actual parent. Closest pushable parent. So we store that before we are parenting it to us, so we can reset this later. This should be way easier. So let's see here. So we can push it. It's parented to us, and it remains parented. Why is that? So if we have a closest pushable, then we want to stick to it at all times and only remove it again when we stop moving. That works with the delay though. Why is there a delay? Update pushing is pushing. If removing is false, then we're not. Find closest pushable. So couldn't you make the block not pushable for a moment until it's pushable, and stay in push motion until stop movement? This also feels very hacky. I know what you mean, but I'm not quite sure if I'm happy with that solution. This is actually a more difficult problem than I anticipated, but that's fine, that always happens. Okay, so now the push, that works, but why can't I move? Oh, so I probably should also, when I parent that to myself, I also should probably ignore this so I don't collide with it anymore. So closest pushable parent. Pushable collider. Get component collider 2D. And then physics ignore collision. Oh, physics 2D. Ignore collision. And I need a reference to my collider. And it's the collider 2D again. I always forget the collider 2D part. So this is my own collider. So basically when I start pushing an object, it gets attached to me and I start to ignore the collision with it so I can move through it basically. So my collider and the closest pushable collider. And then I need to reinstate that collision when I lose the collider. So set ignore to false. Let's see if this works a little better. Dun, 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 dun. Let's see here. Start to push it. So why? What? Wait. Okay, so let's start by just sticking the pushable to us and not remove it at first. So let's just get that functionality working and see if it has the desired behavior when we're pushing the object. It hasn't. Why is that? Oh, what? Because it still has a rigid body attached to it. Alright, okay, so go to the prefab, have a brick. We don't want to have a rigid body here. This should just be a collider. Push it. That looks better, right? And now I can reinstate this so we can let go of it again. Okay, so now this object is just a simple collider. All right. That doesn't work because I set the closest pushable to null here. So I need to change the order of this. And basically when we start pushing the object, we just take on the collider to ourselves. So this way we are still the only rigid body, but our collider grew. So we cannot push this into other objects. Yeah. So there's two things left to do. First of all, I think we should push it slower than our regular movement speed. And also, while we are pushing something, we should have the is pushing and walking playing. And also we shouldn't be able to change directions while we're pushing something. I think we can already do that. Movement model set frozen. Is frozen false? Is direction frozen true? In effect game time false. So we cannot change our direction after we started pushing something, because that's just weird. At least in this kind of perspective, it looks weird. Okay, but why can't I let go of this anymore? Set the direction to frozen. Are we actually able to let go of it then? What's going on now? We're pushing it, we stop pushing it, but we don't detect that we're not pushing it anymore. Why is that? What happened when we set frozen? Is direction frozen? Only is direction frozen is set to true. Set direction. Maybe we're just doing this way too early, this return here. Movement direction. Is direction frozen, but so if direction is frozen, we still and the direction we still want to be able, if the direction is frozen, we still want to be able to return to 0. So if direction is frozen is true and direction is not 0, then we want to return. Because going back to 0 is not changing the direction that our facing direction. What happened now? What? How can that? How can that? This is weird. This is very, very, very weird. Okay, so I cannot use that is frozen part. But why? Why can't I use this? If is direction frozen set to true, then we don't want to do this, and the direction is not 0. Why shouldn't this work? I was so sure of myself. Then the movement direction goes back to 0. If direction is frozen, oh, it's probably because this is being called multiple times. Depending on... Okay. Okay. So set direction is called multiple times. By the different controllers. So if the gamepad control is calling set direction, and the keyboard control is calling set direction as well. So what we can do is, instead of using this immediately, the set direction thing, we're storing this in a receive direction. And then we're calling update direction. I'm sure I'm messing this up right now. Still working though. Couldn't be too bad. I'm sure this is still working. Let's see what the execution order is. Because I'm sure this is working by accident right now. So first of all, the gamepad. So the gamepad, since we're not using the gamepad at the moment, the gamepad sets the direction to 0 and then the keyboard sets the direction. Alright. Yeah, this is working by accident. So what we can do is basically we're resetting the receive direction every frame after we used it. So this way we make sure that we are only using direction from this, or using input from this very frame. And then when we're setting the direction here, we are only setting it if the direction that we receive is not 0. And we do this because basically set direction is being called by all the controllers. So right now this is the gamepad control and the keyboard control. It will be the touch control later as well. And they're all working at the same time. So basically they're all active at the same time, but if you're not using the gamepad, then the gamepad would set the direction to 0 at all times. And we don't want that. Because if for example, as you saw before, the execution order right now is first the gamepad sets the direction, then the keyboard sets the direction. So let's assume that the gamepad sets the direction to I want to move to the right. And then the keyboard, because the keyboard is not used right now because we're using the gamepad, it sets the direction back to 0. So we don't want that. We don't want that. So that's why we're only setting the receive direction when we get something other than 0, and resetting the receive direction to 0 after we used it. So this way we're checking the input every frame, but we're not overriding input back to 0 from other controllers that the user is not using at the moment. I hope that kind of makes sense. But now we can basically, because now we made sure that the update direction is only called once, now we can see that now we can do what we wanted to do before. Check if the direction is frozen and if the direction is frozen and the receive direction is not 0, then we don't want to do anything because the direction is frozen. But if the direction is 0, and this only happens once per frame now, we still pass on and tell our script that we want to stop moving. And since this only happens once per frame now, we know that if the receive direction is 0, the user is actually saying 0, I don't want to move anymore. So there you go, and this works. Now we can push, we can stop pushing, and if we push against an object, it doesn't move, and we cannot change the direction while we're pushing. I mean, it changes the direction a little bit here because we're pushing it against the slope, but I cannot change the direction while pushing the object. Okay, so now let's make sure that we slow the character down. And by doing this, we basically have to set interaction model, or we're in the movement model. So we have our character speed here, and it's being used in the movement. So basically we want to be able to override this. So let's create an override speed value, which is 0, and we're basically just saying if the override speed is not 0, no, something else. Let's also make it a boolean. Overwriting speed, override is overriding speed, whatever is overriding speed. So if is overriding speed is true, then we want to set speed to the override speed. Set override speed We'll do override. No. Enable override speed. Wow. Set override speed enabled. Enabled. Is override speed and override speed. Set override speed to speed. Okay, so now we can just override the speed value in our advanced model. So if when we start pushing, which is here, actually let's put this in a separate function so it's easier to read. Start pushing pushable, the closest pushable. Oh, we don't need the value, basically we can use the start pushing closest pushable and then stop pushing closest pushable. This is just to make the code a little easier to read, because this is a bunch of code and that basically just gets executed to do one thing. So we're going to name that one thing by just putting it in a function. And the same up here. This is a bunch of code that happens because we want to do one simple thing, which is stop pushing the closest pushable. And this is basically just writing self-documenting code here. So, and when we start to push, then we also want to set override speed enabled to true, and then the speed is, let's just use half the speed that we have before. And if we stop, set override speed enabled to false. And we could, I mean, it's probably better not to use just half of the value, but make it an actual property that we can. Yeah, but this is good. So it's a little smaller. Let's make it an actual property here, so we can change this in the inspector. So pushing speed. So we're not setting this to half our movement speed, but to the pushing speed that we are now able to set in the inspector. So our regular speed is 5. So let's put our pushing speed to, I actually want to have it quite slow. So our pushing speed is, let's put it to see what 1.5 does. If that looks good. Yeah, I think that looks really good. And then the last thing we want to do is that the animation is playing the push and walking. So for this we have is pushing and walking set to true already. So let's set up the walk, pick up, pick up the pushing, push idle. Okay, so let's set up the push moving. And I think the transition between those two should be enough. No, let's do it differently. Let's make a substate machine here again. Create a substate machine. Push. And in the substate machine we have push idle and we have push move. And so then we can go back and forth between those two, depending if we're moving or not. Again, zero duration here. So if is pushing and walking is true, then we go to push move. And if is pushing and walking is false, then we go here between those two. We don't even actually need that. And then if we are not pushing anymore, then we are exiting out of this. So if is pushing is false, then we exit out of the pushing state. If is pushing is false, exit out of the pushing state. I mean, we can do it. Let's make it just looks cleaner that way. If we're getting in here and is pushing is walking to true, then we go to this state. And we just need to set this up quickly. Basically, just don't use push idle, but just push move. Down, left, push move right, and push move up. And then basically instead of this here, we're doing all those transitions to push idle. Can I just switch that over? It doesn't look like it. That's too bad. All right. Make transition to exit. If is moving is false, then go to exit. Also, if is pushing. Oh yeah, okay. Those were basically, and then we set up the and we set this up again. So if is pushing, remove the durations. This is so annoying, too bad. Okay, so if is pushing is true, then we go over here. If is pushing is true, then we go over here as well. And if is pushing is false, if is pushing is false and has shield is false, then we go over there. And if is pushing is false and has shield is true, then we go over there. Okay, that should do it. So basically now nothing has changed except we set up the substate machine. And if we're pushing something, we can enable is pushing and walking, and then the pushing and walking animation is playing. So let's see in the view here. Is pushing. Public bool is pushing and walking. Is basically return. So if is pushing is false, then we are not pushing and walking, of course. And then return get moving duration is then 1 and no, No. Basically just if get time in same position is smaller than 0.1, I guess. So animator set bool is pushing and walking is pushing and walking. Basically what we did is pushing and walking is true if we are pushing, of course, and also if we're not in the same position as before. And that seems to work. I was expecting. Oh, so a transition is not quite set up right here. The code is working, but oops. Let's go over to our push substate machine. So if is pushing and walking is false, then we go back. Yeah, the transition wasn't set up properly. Basically, because we're using the, if we're in the same position now, when we start pushing something, but we push it against an obstacle, then so while we're moving it, we're using the push and walking animation, and if we're pushing it against something, we're now in the same position, then the walking animation isn't playing all the time. This is exactly what I wanted. So we're pushing the object slower than our regular movement speed, and if we push it against the wall, then we won't continue. Interesting. Looks pretty good. There's a small bug here that I just found. So if I push and then change the movement direction to so I'm pushing down now and not right anymore. So that's not what I want. Let's see. And that is because, so if is moving is false, or I mean we could save the facing position, facing direction when start pushing, and we can change if this changed. So start pushing, close pushable, facing direction when start pushing, we store this, get facing direction, and then here if is moving is false, or if the get facing direction movement model get facing direction is not the same as the facing direction when we started pushing, then we also want to stop pushing. Hopefully that worked. Push it, and if we go somewhere else, no, that didn't work. Because we're not changing the facing direction. Wait, what? Alright. Still, so it's moving is still true. Because the movement direction is direction frozen to true. and movement direction is not equal to facing direction. Does that make sense? Maybe, let's see. But then we're also having trouble with diagonal because the facing direction is only left, right, up, down and not diagonal, but we can't really push diagonal as well. So let's see. Push here. No, that doesn't work either. Well, I'm actually just coding in the dark now, so that's not a good way. Well, that's a good way to introduce bugs. So I think I'm just going to stop here because I'm not making any useful contributions anymore. Go to the left. No puzzles. Go top. No puzzles. There's a puzzle that we can reach. Let's go to the left here, and there's our puzzle scene. So push this over here, push this over here, push this down, and then we can get a shield. Ta-ta-da! But yeah, so pushing objects, we can strike that as well. We didn't get to the touch controls, which is a shame, but I think we can do that next time. Actually, next week I won't be able to stream because I'm not at home. So but I still want to have I at least want to have a regularity on YouTube so that there is a new stream video every week. So what I'm going to do is I'm going to do another stream tomorrow at the usual streaming time. So tomorrow between 6 and 8 p.m. CET, which is 9 o'clock on the West Coast and 12 o'clock on the East Coast, I'm going to stream. And then, so this way I can upload this stream to YouTube tomorrow. I can upload the stream from tomorrow to YouTube next Sunday. So this way, at least on YouTube, the streams will get uploaded every week, and there's regularity there. Actually, in June will be a little bit all over the place when I'm about to stream, because there are a lot of events on weekends that I am going to, so. But I think I'm going to make a proper schedule, put it up on the website, and put it up in the offline image from the stream, so you guys know when I will be live in June. And so if you like the stream, please follow me on Twitch or subscribe on YouTube, and you can go to letscodegames.com to find all the links to Twitch and to YouTube. And I hope I hope to see you tomorrow again. Have a great Saturday.